Greetings. This is like take 12 of a video where I'm simply trying to take the derivative of y equals 8 times the natural log of x to the fourth. So let's try it again. I'm actually going to work this problem two different ways. So I'm going to kind of split the screen in half here. On the left, I'm going to do a little algebra ahead of time. And I'm going to deal with this exponent using the rules for natural logarithms, the laws of logarithms. And I'm allowed to multiply this exponent of 4 out in front of the natural log function. So I'm really going to take the derivative of 32, 8 times 4 is 32, times natural log of x. Since 32 is a constant multiple, I'll really just take the derivative of natural log of x and then multiply by 32. So let's go ahead and do that. My derivative y prime is going to be 32 times the derivative of the natural log of x, which we know is 1 over x. And I can simplify that to 32 over x. And sure enough, that is the derivative of the original function. Now, if you forgot to use your laws of logarithms ahead of time, you can still take the derivative of this function. What we'll do is, and let me rewrite it here again just to remind you what we're taking the derivative of. I'm going to put parentheses around that x to the fourth just to send home the fact that this is a composition. I'm still going to take the derivative of 8 natural log of x to the fourth. In this case, 8 is a constant multiple, so we'll just take the derivative of natural log x to the fourth and then multiply by 8. So that's going to look like this. We'll have 8 times the derivative of natural log of x to the fourth, which is 1 over x to the fourth. But because this is a composition, I have to use the chain rule and multiply by the derivative of x to the fourth, which is 4x cubed. And when you simplify this, you'll multiply these three terms together and get 32x cubed over x to the fourth. And then, of course, that still simplifies to 32 over x. And so, thank goodness, both of these results match. They're equal. And we just basically use two different techniques to take the derivative of the original function. Hopefully that helped maybe reinforce some of these ideas that we've been working on. Good luck with the rest of your problems.